Geometry, Unit 13, Section 6 and 7. Section 6 is interior angles, and Section 7 is exterior angles. Both, we're talking about circles here. So, for interior angles, um, what we're talking about in this, angle X that's shown here in this circle O, the vertex for angle X is at point P. The center of this circle is point O. So notice that the vertex of this angle is not at the center, and it's not on the circle. Every angle we've worked with up to this point have been one of those two things. Let me get you an example here. Like here we saw a central angle because the angle was at the center of the circle. The vertex was at the center. And we also talked about inscribed angles where the angle was on the circle and it was half the arc. And the same thing for tangent angles. The angle's on the circle, it's half the arc. So we got central angles where it equals the arc. We have inscribed angles where it's half the arc. Tangent angles, again, half the arc, because tangent angles and inscribed angles are both on the circle. But what about an angle that's just kind of somewhere in the circle? It's not on it. It's not at the center. It's in that space in between the center and the edge of the circle itself. We call that an interior angle. And interior angles are different than central and inscribed because they use two arcs. Two arcs. Because, let me go back again and look at a couple of things. Like you trace out this tangent angle, there's only one arc inside of it. And you trace out this inscribed angle, there's only one arc inside of it. And the central angle, there's only one arc inside of it. Now, when I trace out this interior angle, there is only one arc right here. So why am I saying two? Well, the issue is that angle X is not just here. It's also here because they are vertical angles. And because they're vertical angles and vertical angles are congruent, I have to not only look at the arc opposite this angle X, but I also have to look at the arc that is opposite its vertical angle X here. So you're actually going to be finding both of these angles because they're the same. So we need to look at two arcs. In this case, arc AB, and in this case, arc DE. And what it says up here is an angle of vertex inside the circle, not at the center, not on the circle. Interior angles intercept two arcs. The arcs across from the vertical angles. And so that's what we're doing here. And we actually have a little bit of a formula. It's not just as simple as half or equal like inscribed and central. Because there's two arcs, inside angles, the interior angles, the formula is the sum of the arcs divided by 2. It is half the sum. Half the sum of the two arcs. So if I know arc AB and arc DE, add them up, divide by 2, boom, there's your interior angle. So interior, the degree measure of an interior angle is equal to half the sum of the measures of the two intercepted arcs. A couple quick examples here. So I want to know, what is the measure of angle BPA? BPA, that is this angle right here. And if we trace it out with the highlighter, I mean, this is a pretty basic example, you could probably see it. I don't want to stop there, though. I want to highlight this whole line and this whole line, because that'll allow me to get both sides of it. So yes, I'm finding angle BPA, but I'm also finding angle DPE at the same time because they're vertical angles. And vertical angles are congruent. So we got to do the sum of the arcs, half the sum of the arcs opposite them. So the arc that's opposite BPA is 40, and the arc that's opposite its vertical angle is 100. So we simply have to do 100 plus 40 and half of that. So half the sum, half of 140 equals 70 degrees. And so that is the measure of this angle in here is 70 degrees. And of course, this is also 70 degrees. Now I could find these arcs because they're supplementary to 70. That would be 110 and 110. Because we know whenever two lines cross, they create vertical angles, but they create two pairs of vertical angles supplementary to those. All right, this time I want to find arc DE. and what you're given an interior angle to find arcs. Remember, this goes both ways, like for the central inscribed and the tangent. Sometimes you were given the arc to find the angle, and sometimes you were given the angle to find the arc. Here we're given an angle of 50 degrees, and the arc opposite it, but we don't know the arc opposite its vertical pair. So let me just highlight real quick for you for visual. I actually see a diameter here, which is helpful. I don't know if that's going to come in. I don't think it actually does matter here, but you could use it. And a line there. So the way that this is going to work, and I think it's helpful to maybe place an X. So we're trying to find this arc here. Now, if we didn't have this angle, it would be the sum of these two arcs divided by 2. That's exactly what we want to do. We want to use that formula. That 50 comes from the sum of these two arcs divided by 2, and solve this little formula here. And what we can do is we can cross multiply. We could multiply out this 2, cross multiply to get 100 equals 30 plus x. And sometimes if you're real good, you could actually jump right to this and not even write this one, because what you realize is that it's the sum divided by 2. That also means that the sum is double the angle. But if that confuses you, don't worry about it. You can work it out like this. But the sum is double the angle. And that's how we end up with this. And I subtract that 30, making 70 equals, yeah, so we got another 70 degrees here. And again, I could check that 30 plus 70 is 100 divided by 2 is my angle 50. So that's interior angles. What you have to realize is that you're working with 2 arcs and 2 vertical angles, and it's simply half the sum of those 2 arcs. Special note for inside angles: if a chord is perpendicular to a diameter, then the diameter bisects the chord and its arcs. So if a chord is perpendicular to a diameter, so I have a diameter drawn in here. Let me draw in a chord that's perpendicular to it, and I'll show you what that's trying to say. So here's a chord, and it's perpendicular to the diameter here. What we're trying to say is that this diameter bisects this chord, but it's also bisecting this arc. So these 2 pieces of arc are equal, and these 2 pieces of chord are equal. The lengths of the chord is something that we'll discuss in the next chapter when we get to segment lengths in circles. But that's just an interesting thing. If you see a chord and diameter perpendicular, you get a bisecting relationship. So that's interior angles. And now let's quickly talk about exterior angles. Exterior angles are very similar. You take a look at the formula. What's the difference? The difference is the difference. Instead of adding 2 arcs dividing by 2, we subtract 2 arcs and divide by 2, because exterior angles, like interior angles, have 2 arcs that they are working with. So let me show you that. So an exterior angle is simply an angle outside the circle, completely outside the circle. It's not on the circle, not in the circle. Like angle P here is completely outside of this circle. And that's what we're trying to find here. And then you see that there are 2 arcs that it intercepts. It intercepts an arc here, arc AB, and it also intercepts arc DE. And so it's going to be the difference of those 2 arcs divided by 2. So the degree measure of an exterior angle is equal to half, not the sum, but half the difference of the measure of the 2 intercepted arcs. So we'll subtract. And you're always going to do the larger minus the smaller when we're subtracting, because we don't want to get a negative. But really, you could also think of that as like the further one away from the angle minus the smaller one, or maybe the major minus minor, if you want to use those phrases. Exterior angles can be formed a couple of ways. Now, first of all, this might be the first time you've seen the word secant. A secant is like this line here, PE, PBE. This is called a secant because it has 2 pieces. It has an interior part and an exterior part, and it hits the circle in 2 spots. So this would be called a secant. It's not a tangent. A tangent only hits in 1 spot. It's not a chord because a chord is completely inside. Like this AD, we could call that a chord. But if we're going to go PD, it's a secant. PD here, again, is a secant because it hits the circle in 2 spots. It has an inside, an interior part, and an exterior part. And we're going to talk about the lengths of secants again in the next chapter. But an outside angle can be formed by two secants, as we see here. Those are two secants. Or a secant and a tangent, like this, or by two tangents. You could also see an exterior angle formed that way. So a couple of ways. All right, two quick examples. Exterior angle. This arc's inside of it, this arc's inside of it. So it's going to be 110 minus 30 over 2 equals angle P. Minus 30 from 110, we get 80. Half of 80 is, let me just fix that. Angle P is 40 degrees, half the difference. Subtract and divide by 2. The same kind of thing, what if I'm given the angle and I want to find an arc? Again, we're going to use the formula, but we're going to say that 45 equals the difference of these divided by 2. And it's going to be the further one minus the closer one. You know, I don't want to do x minus 190 because that would result in a negative, but 190 minus x divided by 2. So again, it's kind of using the formula backwards to solve for an angle, just like we did for the interiors here. Again, we're going to cross multiply. We're going to see that 90 equals 190 minus x. I'm going to subtract 190, get negative 100, but don't worry, it equals a negative x. So when we divide by negative 1 for everything, we get x equals positive 100 degrees. And so our DE is 100 degrees. So this is your interior, exterior angles. It's got a little bit of a formula to it, but it's really not too bad. It's just either add divide by 2 or subtract divide by 2. Students will flip-flop those two, so you got to remember that interior is some, exterior is different. But your angles should also kind of make sense. You know, like this 100 degrees made sense if this is 190. This does look like a 40-degree angle. If I added these and divided by 2, I'd get 70. This does not look like a 70-degree angle. So, you know, when in doubt, use the eyeball test to check your work too. But that's interior and exterior angles, and this is our end of chapter 13 for angle types, and we will begin chapter 14, segment lengths, in the next video. See ya.